Prepare yourself for something really cool from Virginia. And this brand of coolness is truly Virginian. No, it's not bluegrass music or delicious Virginia peanut pie, which are Virginian and really cool in their own right. This is air conditioning. Turns out, the most technologically advanced commercial HVAC systems are made right here in Virginia. Made in Virginia is brought to you by At Union Bank and Trust, we salute the dreamers, the thinkers, the doers, the believers, the builders, and the makers. Thanks to your vision, hard work, and innovation, you make Virginia shine. Union Bank and Trust, a partner of Virginia business and a proud supporter of Made in Virginia and Virginia Public Broadcasting. Verona, in the heart of Augusta County, Virginia, is where the best and most advanced air conditioners are designed, manufactured, and shipped all over the world. They are called chillers, and for good reason. These behemoths come in sizes ranging from 100 tons to 1,500 tons of cooling capacity. To get an idea of how much cooling capacity these commercial units made in Virginia have, let's make a comparison with a home air conditioner. Even a very large size home system comes in at only 5 tons.
Well, typically, most homes have somewhere between 3 and 5 tons of cooling, depending on the size and configuration. And that would be refrigerant cooling. Our products start at 10 tons of cooling, which is the Scroll product line that we'll be featuring. And we go as high as 2,700 tons of refrigerant cooling at our water-cooled chillers. So you can go from something the size of about 8 feet wide, roughly 10 feet in length, to something that will take a 53-foot trailer to fully just ship it from point to point. And some of our products, when you get into larger water-cooled chillers, can go well over 60,000 pounds in their weight alone. So we're into heavy metal, as I like to call it.
The 15,000-ton, highly efficient water-cooled units made by Daikin Applied in Verona, Virginia, can cool 180 million BTUs in 1 hour. That's pretty cool.
Hospitals, arenas, universities, schools are a big market for air-cooled chillers. Elementary schools up through high schools typically have about 2 air-cooled chillers on them. And then if it's a very big high school, it might go to a water-cooled piece of equipment, which is generally used as the capacities get bigger. It goes up to about 550 tons, which would probably be enough to cool, say, 150 to 200 homes.
Air conditioning roots run deep in Verona, Virginia. The current site of the world's leading HVAC system manufacturer, Daikin Applied, began as a Westinghouse air conditioning facility.
Well, this plant has a long history here in Virginia. It originally started as the Westinghouse facility back in the mid-1950s. And Westinghouse used to be in the commercial and residential air conditioning business. Then another company, McQuay, bought this facility around 1980, and we continued to make chillers here. And McQuay was purchased by Daikin a little over 10 years ago. So Daikin's come in with the goal to be #1 in North America. So we've made a lot of great investments in this facility, and we've made a real commitment to continue to build chillers here in Virginia.
It's been around since '54, so there's a long legacy of this facility and this property. It's been expanded several times and it's grown. So the philosophy we have today, we want to keep that growth going and create more jobs, but also bring more of the products internally and create more of a, I'm going to say, job base for this area.
Along with the manufacturing legacy also comes a great deal of pride in continuing to grow your business while maintaining your position as a global leader in HVAC innovations. Virginia, as it turns out, is a great place to do both.
You know, this facility was built in 1954, and it has been an air conditioning manufacturing facility since that point. The key thing is Daikin bought the original company was because of the chiller applications for the water-cooled products. And they really did not have that technology within their international realm. So they came to Virginia to get that level of knowledge, and today we produce some of the highest technology products in the world.
Well, we have our main chiller engineering group is here. We've recently invested over $7 million in an air-cooled chiller test facility that is right here in Stanton, and that's where a lot of the development work was done for this. We also have engineering resources up in Minnesota that contributed, but the big driver to design and support this product is here in Virginia at the Stanton facility.
There's always a challenge to be the smallest footprint, the lowest cost, the best efficiency, the lowest sound, and we're trying to challenge in every one of those scenarios here in Virginia to ensure that we're tackling each one of those first and foremost. Being an industry leader in this type of product requires not just one approach on cost, you have to fit all of that into your product. So they come to you for performance, for cost, for noise, for certain options, or certain, quick to market or specialized options. So we're able to fit all that in here in Virginia as far as being that #1 resource for all of those applications.
We've just recently redesigned both our lines of air-cooled chillers we make here. And the bigger ones have an inherent technology called variable volume ratio, so we can actually dial in the compression ratio and make the chillers more efficient when they run on a cool day. And it's unique in the industry, and we've really taken the market by storm. And the only place in the world this is produced is here in Virginia.
Daikin Applied manufactures a host of HVAC products at its Verona facility, but at the core of its business are water and air-cooled chillers.
So air and water chillers work in the same similar fashion. They both work under the refrigeration cycle. There are 4 main components: a compressor, evaporator, condenser, and expansion valve. The main difference between an air-cooled unit and a water-cooled unit is that the water-cooled uses water to transport heat throughout the building or outside of the building, whereas the air just uses, air.
All the product lines, we do both an air-cooled and a water-cooled product family for chillers. And chillers are used in large facilities to pump chilled water to and from the terminal points. And we build both product families here at Stanton.
Well, a water-cooled product means that you run water through a chiller. So basically we make cold water. That cold water goes to a heat exchanger, creating cold air. So here in our facility, we have basically everything from flat steel to flat stock that we make, roll, fabricate into a shell, and we do some assembly. So from start to finish, we have raw material into a kind of highly configured product that fits the customer's needs from voltage to tonnage to pressure drop, and fits that customer's exact specifications for that building.
So with a water-cooled unit, it's more robust. You can do a lot more cooling, but there's a lot more setup. A building almost has to be built around this unit. You don't just have the chiller, you have to have the piping, you have to have expensive pumps, you have to have water going through the pumps, water treatment, and there's a lot to go with it. With an air-cooled unit, it's basically an all-in-one unit. You set it on top of the building, you have the air ducts, kind of like similar to what your house has. It's a lot less setup and overall cheaper.
So now that we know the similarities and differences in water and air-cooled chillers, let's see how Daikin builds a water-cooled unit. It all starts with the raw material for the condenser vessel. Using a plasma cutter, a 13 by 13 foot 3/8 inch steel plate is cut to size. Plasma cutter tips range in size from 80 to 400 amps. Here, a 130 amp tip is used. Holes are also cut to accommodate pipe cells. Once cut, the steel plates go through a cleaning and polishing process called shot blasting. Shot blasting uses steel beads under high air pressure to remove any dirt and rust on the steel. Air is also used to separate the shot beads from the dirt and rust. The steel plate is transferred to a rolling machine, where the application of pressure helps to form the shell. The shell or cylinder is beginning to take shape. The end of each side are now welded together using an automated seam welder. Pipe cells are welded onto the condenser cylinder. Holes are cut into the tack baffle end plate that will accept the proprietary spiral wound copper tubes. Brackets are welded into the vessel that the tack baffle assembly will be attached to. Once installed, the special copper tubes are inserted and the tack baffle is complete. End plates are installed. One side is closed, the other has a cell head. The vessel is sealed and submerged in a deep water tank. 200 pounds per square inch of air is inserted and the vessel is checked for leaks. The evaporator and condenser is bolted to the vessel. Copper tubing is installed and brazed in place, forming an airtight fit, which is tested by inserting 250 pounds per square inch of nitrogen and checked with a nitrogen sniffer for leaks. The compressor is installed. The flange and discharge pipes are fabricated and welded into place. Copper piping that connects the evaporator, the condenser, heat exchange, and the compressor is brazed into place.
Most of this is all refrigerant and copper piping, so brazing and the way you put these things together are critical for high reliability and performance. We actually have what's called a brazing dojo here, so everybody in our plant is qualified and trained here in Virginia on how to become an exceptional brazier, and Daikin conducts worldwide brazing competitions with all the other plants around the world, and we'll send contestants there to compete in the World Brazing Championships. So anytime we make air conditioning equipment, you don't want it to leak, right? And we're using a lot of copper, so the workmanship here is very important.
Sensors, valves, and power cables are wired to the control units. Voltage for the unit is specified by the customer. A 3/4 inch foam rubber insulation is installed, and the entire condenser vessel is painted. The water-cooled chiller is now ready for full-function cold water testing. The now completed water-cooled chiller then goes through an extensive array of function and quality control tests. The unit is then prepped for shipment. Unlike the submarine-looking cylindrical steel plate-style condenser vessels that distinguish water-cooled chillers, air-cooled units are more akin to what one would see on a home HVAC system. Of course, these industrial units made in Verona, Virginia are much larger. The manufacturing process for the air chillers begins with cutting and bending the sheet metal to size. The process is called punch and press and is fully automated. This machine is cutting louvers into the panels to allow for the proper airflow to the chillers. Once cut to size with holes punched, the parts, still flat, are sent to the brake press where they are bent to the correct shape. Once bent, the parts are sorted by job and placed onto carts. The carts are delivered to the assembly station or shop as a full set, where the task of assembly begins. the parts are riveted, creating the frame. Copper tubing is cut to length and bent into the proper shape. The tubing is expanded, creating a female end where the male end of the copper pipes will fit together. These parts are also put on a cart and delivered to the assembly station. Copper tubing is fundamental to air conditioning, as copper is an efficient conductor and essential to the exchange of hot to cool air. The heat exchangers, basically radiators coming in all shapes and sizes, are assembled. The component parts for the heat exchangers are copper and aluminum. Aluminum sheets are pressed and punched to size with holes to accommodate copper tubing. When assembled, these aluminum fins will create an array with a large surface area in which copper tubing will run through. Air is inserted into the completed array of copper connections and the system is checked for leaks. When completed and attached to the HVAC system, refrigerant will travel through the copper pipe coils and heat will be removed by air passing over the radiator fins. With all the parts completed and sent to the workstations, the actual assembly of the air-cooled chillers begins. The sheet metal frame is bolted onto large assembly line rolling carts. The compressor and condenser, along with valves and sensors, are secured to the frame with bolts. A secure, rigid fit is essential. The heat exchange radiator coil assembly is attached to the top of the unit. Copper tubing connecting the compressor, condenser, and heat exchange are fitted to one another. Each copper pipe is expertly brazed to assure an airtight fit. The control box and electronic panel box are bolted into place. The control box is wired, making electronic connections to valves, switches, sensors, and power connections to the system. The base assembly and top are stacked, plumbed, and wired into place. Refrigerant is added. The HVAC system is then run through a series of operational tests. Once completed, it is ready to ship.
What's important about a refrigerant system is that you do proper evacuation to eliminate all air and non-condensables in the system. So we go through a complete evacuation process prior to refrigerant charging, and then from there it goes through a series of functional tests to make sure that everything operates as it should.
These large units are shipped all over the world, so they are carefully crated, shrink-wrapped, and labeled. And every unit that leaves this factory floor is labeled proudly with the slogan, "Something cool from Virginia."
Nothing makes me feel better than to see chillers going down the road with a Daikin label on them. And so we're in here every day fighting to grab market share and increase our business and bring more people into work in the plant here.
The biggest success here is continuously introducing new products and new product lines, which says that there's investment here locally, which is a testament to this area, these people in this workforce, that leadership wants to invest here. So I think that in a whole for all of us is a big success.
We employ over 500 people, and we provide those folks with a great sustainable way of life here in Virginia. And really Daikin's initiative around technology and what we're doing on the cutting edge to propel our chiller market and all of our business lines into the future is how we want to give back to the community. So we're very heavily involved with scholarship funding through James Madison University. We have interns from all of our local high schools, our colleges here to really engage them and involve them, and hopefully they'll stay in Virginia after they graduate high school or they graduate college, and they can come work for us. So really being a partner with our local governments, with being a partner with our school systems, and really saying how can we help you, and then hopefully in return that they'll help us by keeping us in Virginia for a long time to come.
It's worked out well for us. We've got a motivated, union, highly productive workforce, and we're competing with people who build in right-to-work states, and a lot of our competitors actually build in Mexico. So we're growing market share on some of our products, and we're making an impact.
I mean, right here, this workforce is great. Just like your family, you spend more time here than you do your actually family. So very accommodating, very outgoing. People care, and they want to have a good job and actually being good. The quality of the product that we make.
The complexity of our operation is something that you can't find anywhere else in the entire world. What we manufacture here is so custom to what the customer requests that skilled labor, I guarantee you won't be able to find it anywhere outside of Virginia. Our people are the best at the best when it comes to manufacturing or coming up with the real applied chiller solution for your business. And it takes the entire team to make that happen.
I'm a Valley resident, born and raised in Waynesboro, Virginia. I have been with the company since 1980. So what's encouraging to me, I've seen parents and now the parents' children also come in and work in the same facility. And certainly we see that continuation progressing. The good thing is, with an international global company like Daikin is, they want to remain number one in the world. So they continue to invest in the local area. They participate. We even locally participate in a lot of the community events.
Our research and development happens all right here in Virginia, and that's what makes Daikin in Virginia so unique, is that we house all business operations around chillers here at our Stanton facility. So everything from our marketing department to our warranty and servicing group to quality, anything that supports making sure that a chiller is delivered on time to the customer is right here in Virginia. So we do get some support from outside, departments and divisions of the company, but like I said, everything that is manufactured here is supported by personnel and resources in Virginia.
I think Virginia has great access to the East Coast where the major customers are, but also has ports that are close by. So if we do have to ship externally, we can ship out of Virginia on some of the ports. But also we can ship to the Midwest and West Coast as well.
What makes it such a great company is our longevity in Virginia. We build a product here that has been made in the same facility since 1954, and our workforce really is the heartbeat of Daikin and the heartbeat of our operation. And some of our people have been here since the facility opened, and they're still working here today. And there's just so many generations of families that have worked here, and they take such pride in the quality of the product that we deliver to our customers. And I think that's why we're continuing to stay in Virginia. That's why we're still here, and that's why we're still manufacturing chillers better, faster, and smarter than our competition, and we'll continue to do so for the next 65 years.
Summers are hot and muggy in our nation's capital, Washington, D.C., which made running the country a brutal affair before the advent of air conditioning. So, who was the first American president to have air conditioning in the White House? Was it A. Calvin Coolidge, B. Harry Truman, C. Franklin Delano Roosevelt, or D. Herbert Hoover? The answer right after this. Made in Virginia is brought to you by At Union Bank and Trust, we salute the dreamers, the thinkers, the doers, the believers, the builders, and the makers. Thanks to your vision, hard work, and innovation, you make Virginia shine. Union Bank and Trust, a partner of Virginia Business and a proud supporter of Made in Virginia and Virginia Public Broadcasting. So, who was the first president to have air conditioning in the White House? The year was 1929, and it was installed by D. Herbert Hoover at a cost of $30,000, allowing Hoover to keep a cool head during the stock market crash of 1929, which started the Great Depression. Next time on Made in Virginia, it's all about sweetness. Yes, Virginia honey, prized for its taste, has its North American roots right here in Virginia as the first colony to import honeybees way back in 1622. Almost 400 years old and still made in Virginia. If you would like to learn more about today's episode or suggest a Virginia manufacturer for the program, you may visit us at madeinvirginia.tv and at wvpt.net.